All right, guys, what I'm going to do is I'm going to show you how the Knuth Morris Pratt algorithm works. What it's going to do, it's going to build this table, and then it's going to use this table to figure out how many characters it could skip to compare it to the large string we're searching here. So we're going to be searching for the substring ABDZ, ABDG. So ABDZ, ABG. So we're going to be searching for this substring right here. But there's a really cool trick that they figured out. So let's take a look at how this thing works. We're going to start building the table. The bottom one is going to represent the match. So if there's a match, we're going to progress the bottom. If there's no match, we're going to progress the top. Even if there's a match, we're going to progress the top. The top's always going to go by 1. The bottom's only going to go by 1 if we find a match at the top. So if you were implementing this, you'd use 2 pointers. I'll show you the Java code in a second. I'll show you the code here. It's on the right. I didn't make this website. It's here. It's an awesome website. You should check it out. It's amazing. So let's do it. There's no match here. That means, all right, so the length, this means the length of my longest suffix, that's also a longest prefix, that's also a suffix, is 0. Okay, so if I get to D, that means the longest prefix, that's also a suffix, prefix, or prefix, suffix rather, is also 0. Again, 0. Okay, we have a match now. So remember, when we find a match, we progress 1, and then we're going to put whatever was here plus 1 there. So we're going to, at the 4th index, we're going to say, all right, that means that my longest suffix, that's also a prefix, is 1. A and A, right? A. Prefix, suffix. They're each 1, okay? Then we're going to go, and this is always going to progress by 1, and we found a match, so we're going to go up by 1. Now it's going to go to 2. So that means that AB, the prefix AB, is also the longest suffix AB, okay? Now we're going to go to D, and we're going to say, all right, we also have a match. So that means my longest prefix, that's also a suffix, is now 3. So ABD and ABD. So my prefix ABD and my suffix ABD are the same length, okay? Then I'm going to go to the final one. I'm going to notice, all right, well, that's not a match, so it's going to go back. And it goes back to wherever this is here, 0. And you know, we don't have anything, so we're done. All right? So we have our table. There's something I want you to notice. Notice 4 minus 1 is 3, 5 minus 2 is 3, and 6 minus 3 is 3, right? That means if we get to here and we make a match, we could shift it 3 over. We could shift it 1, 2, 3 over, or you could just go to the 3rd index. Here you could go to the, or you could go to the 2nd index. Here you could go to the 3rd index. Basically what this is saying is if we get to here and we have a mismatch here, we could skip these characters, because I know that I've already matched the prefix, the suffix rather, with the prefix. I've already matched these two. So that means, well, I don't need to check it again. I already know that my prefix and suffix are 2. I could just go to the 3rd character and skip those characters. I don't have to double check. The other way of thinking about this is, I know that 5 minus 2 is 3. That means if I'm here and I have a mismatch, I could just shift it 1, 2, 3 over, because I've already matched the A and B. It means the same exact thing. Either one you could think about works fine. How many you could shift it, or what index to go back to. The reason why what index to go back to works is because that's the number I could shift it. That's a really, really clever way of doing it. Obviously, I didn't come up with this, right? This is really good. So let's go ahead and finish up. All right, so now we have our table. Let's start comparing. The way it's going to work is this is going to progress if we find a match down here. So we found a match down here. Good, we're going to progress. Awesome. Okay, we found a match, we're going to progress. Great. We found a match, we're going to progress. We found a match, we're going to progress. We found a match, we're going to progress. Progress, there's not a match. So this means, well, what does this mean? I can go back 3. So I could shift it over 1, 2, 3, or I could go to index 3. It means the same thing, right? Which is right here. 0, 1, 2, right? I could shift it back 3. So that's 1, 2, and 3. It's always 1 before my mismatch. See, let's do that again. So there's a mismatch here. Let's just see how this works. I progress, there's a mismatch there. So I look at the one before it. I'm not going to look at this because I didn't match this, right? I didn't match this. I matched these two only. And then I went here and I was like, wait a minute, the A and the D don't match. So this is as far as I got in my matches. So I could shift it over 1, 2, 3, or meaning I could go to index 2. So you'll notice that the visualizer highlights this segment. This is telling me I could go to index 2, or I could shift it over from here, rather, 3, 1, 2, 3. It's the same thing. Okay, now I don't have a match here, right? I don't have a match here. So it's going to say, all right, well, I have to go back to index 0. 2 minus 0 is 2. So I have to just shift it twice. That's 1, 2. That's back to 0. All right, so I'm back here, and now I found a match. Okay, I don't find a match, so I'm going to go back to 0. Found a match. Found a match. Did not find a match. So this is saying 2 minus 0, again, shifted twice over. All right? And you might be like, well, why can't we just go back 2? Well, we didn't match. We didn't get to the suffixes yet. In order to really take advantage of the suffixes, we have to pass the proper prefix, get to the suffix, and then go back to skip the characters we found in the prefix. So if we didn't get to the suffix yet, we're not skipping any characters in the prefix. If we have a mismatch in our prefixes, we just go back to the beginning, okay? So we're just going to continue. Have a match, have a match, match. Again, this goes over, have a match, I have a match, I have a match. Well, I don't have a match, actually. I think I made this substring without a match. It's okay. So this is saying, all right, well, let's take a look. So when I did this, I have matched everything ABD, ABD, ZAB. So I've done ABD, ZAB, right? I've done up to here. So this tells me, well, what are my prefixes I've matched? AB. What are the suffixes I've matched? AB. I have a mismatch here at the 16th index. I have a mismatch. So that says I could go back. 6 minus 3 is 3. Or I could just go to 3, right? Same thing. So 0. So that would be a 1, 2, 3 shift. It's going to go hop back right here. It's actually 1 before it, sorry, because I matched up to here. So I could go to 2. You don't go from the index you missed. You go from the prior index. So you're going to go 3. 1, 2, 3. There we go. I go over. I don't have a match. 1 minus 0 is 0. 1 rather, so I don't have a match. And I go, and I go. In this particular case, in my geniusness, I didn't put a matching substring. I probably should have. Okay. So this is the pi table. So what you're doing is, if they match, you're increasing I and j. And if they don't match, j is always increasing. So j is the one that's always going through. That's really all it is to it. It's simple enough. Else you're just saying I gets pi j. You didn't find a match, so it's going back, right? That's the pi table code. It's pretty simple. And then the main matching code is right here. So you're saying if substring.char at I equals substring.char at j, and I is equal to substring length minus 1, that means that you have reached the end of the substring. You're good. You've found a match. So this right here is returning the index of the match. That's all that does. Else what you do here is you're increasing both, so the characters match. And here the characters didn't match, so we're backtracking in our string. So that's just a little bit of backtracking. So that's the code. Again, you could Google that. The main thing is understanding how the algorithm works. So thanks for watching.